Forces, everybody seems to be just thrilled with forces. I have no specific comments about forces. Circular motion and gravity, whatever. People, I mean, basically, circular motion and gravity is basically just saying whatever force in the problem equals mv squared over r. That's pretty much every one of them. Okay? And then finally, here's the other important thing before we actually do problems, is rotational motion. Okay. So one thing that was kind of revealed when you did the homework from the help sessions is that we kind of, I thought I did the kinematics part, and I think we kind of blew it off. Okay? So our whole philosophy of speeding up the mechanics in this class was to minimize circular and rotational motion. Right? That's kind of how we did it. We usually would spend like 3 weeks on this. Okay, and we just sort of rammed it through in a couple weeks. And therefore, we're not asking as many questions about it on the exam, okay? And I forgot to even cover the kinematics. So rotational kinematics is part of it, okay? And we're going to give you those equations. Those equations are going to be added to the equation sheet. I think I might have written it wasn't in my notes though, that as you watch something rotate, and maybe the torque gives you the angular acceleration, then you can actually track the theta just like the distance. The final equals theta initial plus the theta dot t plus 1 half t squared. You can keep up with how the angular velocity changes in time. We're going to do one. Omega final equals omega initial plus alpha t. Hopefully these sound familiar. You can combine those to make the combo equation even matches. Omega final squared equals omega initial squared plus 2 alpha delta theta. Like how far did it rotate around? Okay? So you use those just like 1D kinematics. Okay? And they will be on the equation sheet. So we're adding those, I guess we're adding that. Okay? So rotation on there, it's important. Torques are on there, but I'm just saying it's not like the whole thing. Okay? Okay, let me see if there's any good questions. No, they're all good questions. You're all brilliant. So they were asking, do you suggest doing the suggested problems or the practice exam? Is the rest of their text. So I don't know at this point. If we don't have time, make time for both. Do we need to know the momentum and impulse? You don't need to know momentum and impulse. That's the first time I've said those words in this class. So if it's a word I have not stated, you do not need to know it. Is the velocity in the y always negative in uneven trajectory? No. So usually when you throw something in a trajectory, you initially give it a positive y. If you assume y is up, an object going in a trajectory starts with a positive y and it ends with a negative y. And right here it's vy is 0. So yeah, so the acceleration is always negative. Maybe that's what you meant to say. There we go. Just a few more, and I promise we'll do the problems. This, I don't know what the balance should be. I don't know what I'm doing. Do we need to know non-uniform circular motion? We didn't really. That's one of the things we kind of sacrificed, was non-uniform circular motion. Okay, now wheels. Another thing we sacrificed is wheels. We're not going to do any wheels. And by that I mean a wheel rolling on a surface. Okay, so if you're doing practice problems with a wheel rolling down an incline and how fast is it going, we left that out. That's how we shortened torque and rotational both. Okay? Now you will still think about round things turning, but it'll just be something turning on its own axis. It won't be like translating on this surface and then turning on that one, and that's all very confusing. It's beautiful physics, we love teaching it, but we had to shorten things. So there will be no rolling wheels. That's a very kind of common problem you find in reviews, so don't obsess with those. Okay, what units is the angle in? Radians or degrees? How do you get alpha from centrifugal acceleration? Oh my god, I don't know. Those are completely unrelated. Alpha and centrifugal acceleration, completely unrelated. The practice test has a question on jerk. That's how we got calculus into the practice test last year. How will we get calculus into the test this year? Find out tomorrow night. Can you do inertia and torque practice problems? I guess that means please. Okay, here we go. Not going to that anymore.